trapped in a lip, plunging straight to the bottom of open season ways of life we've forgotten. I keep having dreams. Amy worked in a bar in Exeter. I went back to her house and I slept beside her. She woke up screaming in the middle of the night, terrified of her own insides. Dreams of pirate ships and Patty Hearst, breaking through a life over-rehearsed. She can't remember which came first, the house, the home, or the terrible thirst. She keeps having dreams. And on the worst days, when it feels like life weighs 10,000 tons, she's got her cowboy boots and car keys on the bedstand, so she can always run. She could get up, shower, and in half an hour she'd be gone. I keep having dreams of things I need to do, of waking up and not following through. But it feels like I haven't slept at all when I wake to a silence and she's facing the wall. Posters of Dylan and of Hemingway, an antique compass for a sailor's escape. She says you just can't live this way, and I close my eyes and I never say I'm still having dreams. And on the worst days, when it feels like life weighs 10,000 tons, I sleep with my passport, one eye on the back door, so I can always run. I could get up, shower, and in half an hour I'd be gone. And come morning, I am disappeared, just an imprint on the bed sheets and by the roadside, with my thumb out. A car pulls up, a boat's driving, and so I climb in. We don't say a word as we pull off into the sunrise.
Aha! There we go. Can you hear me now? Sorry, guys. I forgot to turn the mic on. Anyway, hello. Welcome back to the next iteration of Forensic Anthropology with me, Kate. Thanks for coming and hanging out with me again today. I've got a bit of a quicker lecture today. My parents are in town in Albuquerque, so we've got some fun stuff to do. But I wanted to make sure that I got to hang out with you guys for at least a little bit today. So what we're going to be talking about today is the next step in any forensic anthropology case, and that is determining medico-legal significance. So I kind of touched on this last week, that medico-legal significance is the first thing that you have to do when a case is potentially found. And essentially what you are doing here is figuring out if it's truly a forensic case or if it's something else. So that's really what it is. And there's three main things that you have to do in order to do that. And it's figure out, are you actually looking at bone, which is not always the case. Are you actually looking at human bone? And it's very commonly not human bone that's found. And then if it is human bone, is it actually modern? And so we'll kind of talk about all the different ways that you can make all of these different determinations. So I don't have any fun videos this week because, I can't always have John Oliver producing me lovely videos to talk about that are funny. But I do want to try and have more videos on here, and we can kind of break them down and talk about what's right or wrong with them. I am going to try and do that for most of these, if there's one that's kind of relevant. There was not one for this. I looked this morning to see if there was something that might be relevant for this, but there's not. It's kind of it's an important step in any case, but it's not something that people tend to talk about very much. But anyway, how are you guys doing? Let me know what you guys are up to in chat here. Do you have a good weekend? Do fun stuff? I went to a winery and saw some balloons because it's Albuquerque's International Balloon Fiesta right now. So that's pretty exciting. But anyway, all right, let's dive in and talk about medico-legal significance. Okay, so the whole point of determining medico-legal significance is that you're trying to figure out if a given set of remains or anything that's found that might resemble remains, if it's within a medico-legal context. So here's that same definition of medico-legal that I put on last week. So it's any investigation of human remains for identification purposes and or criminal prosecution purposes. They're not always both happening. Most of the time you're going to try and identify somebody if it's possible. That's the first goal, and that's really something that has to happen in order for the second part of this, the criminal prosecution step, to actually happen. You can't really find out who did something to somebody if you don't know who the person was. So unfortunately that second part of this definition is not all that common because it is very difficult to actually find out who your remains are from, and then also try and figure out who might have done something to them. So it's pretty difficult sometimes. But that's the formal definition of medico-legal context, and that's really what we're talking about here, is figuring out if our remains have medico-legal significance, which means that it is actually forensically relevant to us. So it does require an investigation, either by an anthropologist or someone else. Hey, Autopsy, thanks very much. Glad you could join us. So that's the main context that we're working in here, and the sort of outside of the medico-legal context is an archaeological context. So pretty much anything that is actually human remains, but is not medico-legally relevant, that's most often going to be an archaeological context. So it's older than we're looking at, and probably not something that actually involved foul play. It could have, but it's so much older that there's really no way to tell, or at least there's no way to investigate it. So All right, so how do we actually do this, determine medical legal significance? And there are 3 ways to do this. And it's really, I guess it's not 3 ways, it's 3 steps that you have to get to in order to actually determine this. So the first one, like I mentioned, is going to be, is it skeletal material? Are we actually looking at a bone here as opposed to a stick or whatever? If it is bone, is it human? If it is human remains, is it contemporary or modern? So that's within a particular time period. And I'm going to go through each of those and talk about how we can tell these. So the fun thing about this particular talk is that this is actually something that pretty much anybody can do, right? You go out, take a hike in the woods or wherever, and maybe you come across something. Maybe you are digging up a hole in the ground in your backyard or something to try and put in a tree or whatever it is, and you come across an old pet burial or something like that. All of these things that I'm going to talk about today are things that you can kind of do if you know what to look for. You can tell a lot of this stuff from what you just come across in daily life, which is pretty fun. Oh yeah, finding archaeological remains would be super exciting. It's kind of always been a weird fantasy of mine that I would like be on a hike somewhere and stumble across a crime scene. And it sounds morbid, but it's really not what it sounds like. I've always just wanted to do that because I can go in, I can find it and be like, okay, if there's one person, or I guess probably one of many people that this qualifies for, but if there's one person who could find a crime scene and not screw up the crime scene before they do all the right things to it, it's me. So if I found it, I would not go in and screw up the crime scene. I would know who to call and know how to secure the scene and stuff like that. So like that's actually a pretty good outcome if remains are going to be found. So yeah, you have to be a jogger to find a crime scene for sure. That's always the way it goes. That or like you're, some meddling kids who are like 12 and they're out in the woods doing naughty things. And by naughty, I mean like mischief, not naughty. I mean, who knows, but that is not what I meant. So I would love to be able to stumble upon something like that. I never have. I've definitely found animal bones, and a lot of them are behind me, actually. Just FYI, this one right here, this skull right here, is not real. It is a cast made out of kind of like a foam material. So this is not actually a real skull. It's really not kosher to have human remains at home. It's kind of a faux pas. You should probably give it to a museum or something. But it is really common. It's less common now, but it does still happen. But it is actually illegal to buy and sell human remains. So I just wanted to clarify that. It's not real. So, but I do have a bunch of other real stuff above me, which you can't see, but anyway, so this is actually stuff that you could do out in the middle of nowhere to figure out what you're looking at. So that's kind of fun. All right, so let's keep going. So the first one, like I mentioned, is it skeletal? So are we working with bone or are we working with something else that might not be bone? And this is actually really common. Stones, particular types of stones with like a certain coloring, sticks that have degraded a lot, even like really compact seeds and stuff like that can actually resemble human bone or just bone in general. So it is possible that you could find it. Hey, Big Ninjawa, what's up? It is possible to find something that really looks like a bone. I actually have a stick somewhere. Oh man, I should have found that. I have a stick somewhere that's it's actually a piece of driftwood from Lake Erie. And it looks so much like a radius. So that's this bone here. It's one of the two, oops, sorry. That's the one on the thumb side of your arm. There's 2 of them here, and this is the radius. And it looks like this chunk of a radius so much, it's actually pretty ridiculous. Oh, you know what? I think I left that in my master's program on a test, because I brought it in to use as a test question. and I think I left it there, now that I think of it. But yeah, so it looked so much like it. It even had the same features that are normally on that bone. It was actually pretty crazy. So it does happen sometimes. So you have to basically know human osteology well, the normal range of human variation in osteology, which is the study of bone, in order to kind of figure out what you're looking at. So in a couple of these, the images that I have here, these are all, I think they are rocks, yeah. And they all look, they don't really look like human bone, but they look a lot like some non-human calcanei. So the big bone in your heel, the one that's like the back part of your heel, that's your calcaneus. And it's a different looking bone in other animals as opposed to a human, but a lot of these actually look a lot like it. So it would not be unreasonable to potentially mistake it for that. So the whole point with this is that you have to really, really know normal human variation in the skeleton in order to figure this out. So let's talk about how else we can do this. One thing I do want to mention here is that there are a lot of common mistakes with this. It's really strange, actually, in a burned setting, so like a fatal fire scene or even just a regular fire, even if there's not human remains there. There are many materials that when burned, they look so much like bone. It's so crazy to think that, but anything that is tubular, which I'm like, tubular, I don't know why I would ever use that word in any other setting, but anything that's kind of spongy, perhaps something that's sort of spongy on the inside but harder on the outside, that kind of thing. If it gets burned, it will look so much like human bone. It's actually pretty crazy. Two of the biggies that are most commonly mistaken for bone are burned electrical wire insulation or other thermal insulation. So that like fiberglassy kind of cotton candy-like material, when it burns, it just kind of like, and it condenses and it ends up looking like these giant clumps of material. And you get all these kind of holes in there, and it looks uncannily like bone. It's actually pretty funny. So in a burning context, you have to not only know normal human variation in terms of the skeletal variation, but you also have to know how the bones that you would normally see are going to respond to fire. Excuse me. So that's something that we'll talk about much later when we actually get to trauma stuff, because there's a whole set of principles that govern how we think about how fire affects bones. And so you have to know all of that stuff too. So not only do you have to recognize regular bone, but you have to recognize bone that's been altered by fire or whatever. So those are two biggies. And if you guys have questions, please let me know. Feel free to interject, and I will answer them as they come up. All right, so what's one of the first things we can do to figure out if we're dealing with bone or not? So probably something you guys are familiar with. Bones are what is known as radiopaque, which means that they show up on an X-ray. And so if you're trying to figure out if you have a piece of bone in front of you as opposed to a stick or whatever it is, you can X-ray it. So if you put one of these things through an X-ray and it does not show up how you would expect a bone to, probably not bone. You do still see things other than bone on an X-ray, like you can actually see some soft tissue if you X-ray a human, for example. That does happen, but it's not going to kind of light up in the way that bones do, and that's what it means to be radiopaque, basically. So that's one way you can do it. Then we also can look at the internal microstructures of bone. So sticks, if you open it up, it might even, if it looks like a bone, it might have, wood on the outside and then there's a cavity in the middle or something like that. And that's actually pretty similar to what some bones, especially long bones, would look like. But you're not going to see the same sort of biological structures inside of a piece of wood as you would inside a bone. So this is called histology. And this picture that I have here is a thin section from a bone. A thin section is really, it's exactly what it sounds like. Someone took a very, very, very tiny thin slice of the cross section of a piece of material, and then you can, because it's so thin like this, you can put it on a slide, put it under a microscope, and actually look at the internal structures, much the same way you would if you had like a blood sample or something like that. So what you can see here, there's a couple of two big round areas. Oh yeah, I can use my mouse. There we go. So you got this one here and this one here. So this is what's called a haversian canal, which is the very center of a single bone cell, which is called an osteon. And so this whole thing right here, this is one osteon right there. This is another one. This one, I believe, has gone through its full life cycle and become an osteocyte, which is sort of a permanent thing, whereas this one is, I think, still a remodeling bone cell. So essentially, you can look at this thin section and say, oh, I see osteons here. This means that I'm looking at bone as opposed to looking at wood or whatever. Okay, so now we know it's bone. We've seen some osteons, we've looked at it through through an X-ray, and we can tell that we're dealing with some bone here. Now we need to figure out if we are dealing with a piece of human remains or if we're looking at non-human remains. And by non-human, I literally mean anything else. There is another word that gets used a lot in this context, it's faunal remains. And that literally just means non-human animal remains. And the way you can tell this, and there are a bunch of different types of differences, but the main things that we're looking for here are differences in body orientation and locomotor strategies. So obviously humans are upright. We walk upright and our bones reflect that. Whereas a dog, for example, is going to have many bones that look very similar to humans. They're the same bone analogous across species. So like they have a scapula, we have a scapula. But the way those are oriented in the body is not only reflecting the overall body orientation in terms of upright versus not, but it's also reflecting the different locomotor strategies between the two different types of orientations. So in this image here, we have a human who is sort of walking quadrupedally here, just like this dog. And you can see there are a lot of differences. All of the bones in this image are analogous. So all the different colored bones there are showing the same bone in both the human and the dog. And you can see how that orientation of being quadrupedal for a human is really unnatural. That's not something that is very comfortable. And our bones don't really fit that way. At least they're not built for effective and efficient movement in that orientation. So those are the main things that we're looking at, and basically the different body orientation, the different locomotor strategies, they result in a bunch of different changes that you can actually see on the bones that you are looking for that can tell you if you're dealing with human or non-human. Okay. All right, so one of the most obvious ways that we can tell human versus non-human, and some of this is locomotor, some of this is just evolution, basically. We have very particular skeletons, and so do other animals. And so they are going to have things that we might not have, or at least have something that's somewhat different. And these are three examples of this. So most other mammals, not necessarily apes, but many other mammals will have a tail. We technically still have a tail. That is our coccyx, or our tailbone, but it's much reduced. It's sort of what they call a vestigial organ, or vestigial appendage, I suppose. So we still technically have some of these elements that count as tail vertebrae, sort of. But we aren't going to have the same number of them as everywhere else, and they're going to be much reduced. They're very tiny, and they all kind of fuse into one bone usually. So you're not going to see like multiple vertebrae like this. Okay, so that's one. That's a pretty obvious one. Then we have these called metapodials. So that's these guys down here. These are what many ungulates have. So ungulates are things like horses, cows, deer, that kind of thing. These are actually deer metapodials. Metapodials are the forearm, essentially, of an ungulate. So you've got your hooves here. And instead of having the two, actually no, I'm sorry, metapodials are the foot. So it's like your lower leg. Sorry about that. You have something similar in the forearm, but these are specifically foot ones. So where we have two different bones, either in the forearm or in the lower leg, most of these ungulates are going to have these instead. So we do not have metapodials at all. So this isn't a situation where we have the same bone, it just looks different. These are actually bones that we just don't have. So these are kind of interesting because they have a bunch of features on their ends here where the joint surfaces are that look very different, and this is like super signature of non-human, and that's actually something I'll talk about in a second. And then we have our third example here, and this is what's called a baculum. So plural would be bacula here. And this is basically the penis bone, and this is something that humans do not have, but all other mammals do have. So your dogs have them, monkeys have them, apes have them, but humans do not. So this is actually something that humans lost along our lineage. So we just don't have them anymore. So if you find a baculum, you know you're definitely not dealing with a human. I think we talked about the baculum on an old episode of Science Happy Hour where we looked at somebody who was trying to claim that pair bonding in humans might be the reason why we don't have the baculum, because it's essentially the baculum is let's just say it's helpful when you're in more of a promiscuous mating scenario, like in chimps where you have one male chimp who's trying to mate with a bunch of different females. So somebody was talking about that, and but we did talk about kind of the lack of a baculum in humans. We had a baculum in my old master's program in our bone lab. We had a whale baculum. It was like easily, I don't know, 2 feet long, something like that. And it was broken in the middle of it. Like it had healed, so it was like this long, and it had broken, it fractured in the center, and then it healed kind of like this. So there was like a bridge of bone that was created there when it healed, but then it had healed like misaligned, so there was kind of always like a weird crook in it. That poor whale. Oh, it was pretty funny though. Okay. So back to histology a little bit. This is another way that you can tell human versus non-human. So those same bone cells that we can tell just that it's bone, there are going to be differences in the way those bone cells look between humans and other animals. So in this image here, this is in letter A. Those are human osteons. And letters B and C, those are non-human osteons. And basically the main difference here is that the human ones here are kind of haphazard. They're sort of all over the place. They overlap each other. They're just kind of really irregular in their orientation relative to each other. Whereas the non-human osteons are way more evenly distributed, and they're kind of lined up. So you can see in both of these, it's really, really clear that they're all just kind of in a row. There's individual rows of them, and they're all lined up. This one especially in C is just like, pew. And that's just not something that we have in human bone. It's much more overlapping and kind of haphazard. So that is a very clear way to tell this. This is usually what we would do if we can't identify what the bone is otherwise. So if I can't tell if it's a metapodial, for example, from the actual morphology of the bone itself, then I'm probably going to look at the osteons to try and figure it out. It's usually most often used when you have a fragment of bone. So something that's really small, you might not be able to see all of that informative morphology. You can only really see what's inside when you look at the bone cells. Okay, so here's where I'm going to get into some morphology differences. So the big things here are the articular surfaces, which means the areas where one bone is going to kind of joint up with another bone. So all of your joints, which could be joint in your knee, could be joint in your shoulder, could be joints in between individual vertebrae or whatever it is. Any point where one bone is going to touch another bone, or usually there's cartilage in between, but essentially they're kind of touching. Those are all articular surfaces. And that's really just a fancy way of saying that they touch each other. But the term that we use for this is articulate. So my humerus articulates with my radius. So that's what that is, articular surface. And it's basically just your joint surfaces. And here's those metapodials again. So that's these guys here. On the right here, we have a human foot. And you can see all of these individual joint surfaces here. They're kind of, they're sitting sort of right next to each other. There's a good little sort of shape that corresponds between the two of them. And they're really rounded. So this particular bone, this is the first metatarsal, which is, it's part of the bone that makes up the arch of the foot. This end is super rounded, and then the bone that is articulating with it is also super rounded. That is something that is very characteristic of human bone morphology at the joint ends. In non-humans, a lot of the times, at least the ones that we tend to come across, this does not necessarily include other primates. That gets a little bit more nitty-gritty because their anatomy is very similar to ours. Still, there are big differences, but it's not as much of a difference as this. So here you have these metapodials again. If I can get my mouse to work, there we go. So the biggest difference here is that you have a lot of these sharp ridges. So you can kind of see like each one of these has like 4 or 6 of them, depending on how big they are. And those are very characteristic of non-human bone, especially ungulate bone, which is most oftenly what ends up being mistaken for human bones, that and other mammals. Obviously, this is mostly specific to North America, but there's a lot of overlap with Europe and places in Asia. There's a lot of the same kinds of animals. It might just be minute differences in species and stuff like that, but the principles are pretty much the same. Okay, so then another big difference, and this one is another fairly obvious one, is our teeth. So we have a particular number of teeth, and our teeth have a particular shape to them. And this is all based on function. So the types of foods that you're eating is potentially going to dictate what adaptations you have on your teeth. For example, on the left here, we have a human mandible. So this is our lower part of our jaw and all the teeth there. And then on the right, we have a dog. So they look very obviously way different. And there's a few specific differences here. So first, we're gonna have differences in what's known as the dental formula, which is essentially the number of teeth that you have within each particular class. So in humans, we've got 4 different classes of teeth. You have your incisors in the front, then we have 2 of them. Then we have 1 canine, and then you've got 2 premolars, and then three molars behind those back in the cheek teeth. And that number does vary, but for the most part, as a species, humans have a dental formula of 2, 1, 2, 3. So you've got 2 incisors, 1 canine, 2 premolars, 3 molars. So that's what those numbers are coming from. And we have that in all 4 quadrants of our mouth. that can change depending on the species. You might not have that same formula across the entire mouth. Or if you just have normal variants, like you're missing a tooth over here or something like that. So in a dog, though, I believe their formula is 3-1-3-3. So they've got actually 3 incisors, then a canine, then 3 premolars and 3 molars. And you've got these particular teeth here, the ones that they're using to kind of chomp down on stuff. Those are called carnassial teeth. And it's basically a carnivore's dream to have these teeth. These teeth are specifically kind of adapted for shearing through meat, essentially. So all of these like big spikes on them are for shearing through meat. And so that's a big function and appearance difference that we don't really see in humans. Ours are much more boring. They're kind of round and they've got some bumps, but they're pretty boring. So those are the 2 big ones. It's the number, that dental formula, and then also the shape of them. Okay, so then we do have some common mistakes here with the human versus non-human bone. And this is the most common one. It's actually pretty weird. Like, you wouldn't necessarily expect this to be true, but bear paws are very, very similar in appearance to human hands. So on the left here, I just have an image of the bones in the human hand. In the middle, I have a picture of the bones in a bear paw, specifically a black bear. And then on the right there, it looks a lot like a human hand. It looks like just like a severed human hand, that somebody might find this and think, oh wow, I'm dealing with a human hand, I've got to do something about it. But that is actually a black bear paw. It's got some kind of desiccated tissue on it that's kind of mummified, but that is a black bear paw. It looks a lot like a human hand. So this is actually the one thing that is most commonly misidentified as human. In my master's program, where we had 100+ cases per year that would either recoveries or consultations or whatever it is, I would say, so like maybe 30% of them were, is this bone or not bone, or is this human versus non-human? So a lot of them, they end up getting a case number and it's a formal case, but it's really just, they sent us some remains and said, is this human? Do we need to do something with it? And then we would say, no, this is not human. So this is not our purview. But I would say like maybe 10% of those non-human ones that come in are probably bear paws. It's super, super common because it's just like you find that if somebody who doesn't necessarily know any of this stuff, which even with all that tissue on there, even like I might not know that out in the field. Very, very commonly those ones come in and we just have to say, nope, this is actually a bear paw. No need to do anything else. So, okay. All right, so now that we know, we've got our remains that we're looking at, we know we're dealing with bone, we know we're now dealing with human bone. So now how do we figure out that last question that we have to determine in order to get at forensic relevance? And that is whether or not it's contemporary. So are we dealing with contemporary human remains, or are we dealing with remains that are more in the archaeological context? So generally, the definition of modern or contemporary remains is within about 50 years. So obviously that range is sort of always changing in terms of dates. And right now in 2017, we're basically going back to 19, I can't do math, it's Monday, 1967, right? Yeah. And so basically, if you're in the 60s and up, it would potentially be forensically relevant. Generally, this is a statute of limitations thing, so and kind of information thing. So if you find remains that are super, super old, potentially beyond 50 years, so say between 50 and 100 or something, there might be some evidence of foul play. So maybe that's something that could be forensically relevant. But if I'm looking at remains that are like 70 years old, that maybe it looks like there's a gunshot wound or something like that, yeah, it looks like it might be forensically relevant, but there's almost no information at that point. You'd be able to get some stuff from the bones, and that's about it. But like the chances of actually figuring out who that person is and who might have actually done it is next to nil. It's just not going to happen. So, Cannibal Jones, thanks so much for the follow. So within about 50 years is generally what we consider to be potentially forensically relevant. And anything beyond that is going to be part of the archaeological context. The other part of this is that you could just end up with, even within 50 years, you could end up with, you find a burial that just kind of came out of the ground or something like that. And that's not necessarily forensically relevant, even though it constitutes modern remains. That's just a burial. That's supposed to be there. But that does happen. Yeah, we got to find Jimmy Hoffa. That's totally true. It's probably even too late for that, or at least close. And when you're doing this, you end up with kind of three main time periods. You end up with the modern, so that's kind of within 50 years. Historic is beyond 50 years, but up until written record. And that could be different depending on what area you're in. So written record for North America is going to be different than written record in Europe, for example. So that kind of varies what that historical period ends up being, depending on where you are. And then anything before that ends up being called prehistoric. Most often, at least in New Mexico when remains are found, it's either going to be modern or it's going to be prehistoric. We do have some old cemetery sites that have been excavated, and that would be solidly within the historical period. But most of the remains that are just sort of found out wherever are either going to be modern and probably forensically relevant, or they're prehistoric. And one big thing here is with prehistoric remains, especially in New Mexico, many of those are going to be Native American. So, and that's a whole other can of worms. If you find Native American remains, there are very specific laws that are involved in regulating the excavation process and what you do, because there's a big push to make sure that the treatment of those remains is in line with what the related tribes or pueblos or whatever group, what they would want their ancestors to be treated like. So there's a whole bunch of different things. You have to have a specific person on the site during the excavation who's surveying all of these things, making sure everything is going the way it should be. So that's a whole other thing, but I won't really talk about that so much today. Is it easy to determine the age of the bone? Do you mean the age of the person, like the age when they died, or the age of, like, is it within 50 years or whatever? Within 50 years it's pretty easy to do. I would say it's easier to determine the time period of the bones than it is to determine the age at death of the individual. That's a whole other big topic. Yeah, okay, within 50 years, yeah. It's actually pretty easy, and I'll kind of go through the different ways that we do that right now. Thanks for the question. So one of the big ones here is, are we going to find any associated artifacts with the remains that we have? So if we see something like funerary remains like these, so this is casket hardware. You've got on the left, you have basically in most caskets you end up with a bunch of hardware that sort of holds handles on, or the like bars for pallbearers to carry the casket, that kind of thing. So you might find a whole bunch of this. And if you have these funerary remains, you know you're dealing with a burial. So this is a casket, this is somebody who was buried at some point. That could be modern, that could be historic. But neither of those is going to be forensically relevant, because that's somebody who was buried somewhere and they're supposed to be there. What's cool about this is that there's a big contribution for archaeology here. So all of these artifacts that you might find with a casket are able to be aged, so to speak, based on their style. So you actually have tons and tons of historical archaeologists who specifically study how the styles of these particular pieces of hardware change over time. And so you can actually look at these. So like this one, for example, look at the style of this particular one, look at the style of this, and then basically look at how those styles evolved over time. And you can actually pinpoint maybe even a decade where they came from. So that would be a really cool way to figure out, was this person buried in 1925 or 1935 or whatever it is. And it's definitely possible to do that, and it's actually pretty cool. So if you find those kinds of things, usually you're going to end up bringing an archaeologist to be involved, so that they can kind of do their magic. So that's one way, but this could be both modern or historic, but if you find these things, they're supposed to be there, so not forensically relevant. So even though this is technically, could be modern, not something that we're going to investigate. So here's another thing. So body arrangement. So wherever you find those remains, if you find them in a burial context where everything's sort of still in association with each other, which is not always the case, if you can actually tell the orientation of the body of where it was buried, that's also potentially going to tell you something about whether it's forensically relevant or not. This isn't necessarily modern versus historic, because a lot of these things overlap throughout modern versus historic, but it's really giving you, do we need to investigate this? So really what this comes down to is the degree of care that was given to that body when it was laid down wherever it is. If you're looking at a burial, whether it's with a casket or not, depending on the time period, most of those burials are supine, which means that you're just kind of straight up and down. You're just laid out on your back, straight legs, everything. There's another very common burial position, and that is the prone position or flexed position, where basically your legs are flexed. So that's a picture of this here. This is also pretty common in burials, mostly older burials, more like prehistoric burials. There are many different cultures that bury their dead in different ways, and so you might expect to see a flexed burial as opposed to a supine burial, depending on where you are and in what time period. And so you might find both of these different kinds of burials, and those are not necessarily forensically relevant. The way you might be able to tell that is if you have a flexed burial that just kind of looks haphazard. So I have the arrangement is erratic, so like your bones are kind of all over the place. You don't look like you've been kind of laid down to rest in a very particular position. It's just that they just happen to have landed there when a body was thrown into a pit or something like that. That's probably not going to take a great level of care to do that. Somebody just threw the body into a pit. And that's probably going to tell you that this might actually be something that involved foul play. That's not always true. Certainly, like, there's probably a zillion different TV show episodes that show someone who maybe kills their mom or something. So it's like there's some weird difference in how they treat their mom as a victim as opposed to somebody else because there's a relationship there or whatever it is. Like, those are all kind of, that could happen. It's all dramatization, obviously, but that it's a reasonable thing to expect that there might be differences there. Could a killer effectively hide a body by putting it in a casket? Ooh, good question. I guess I need to decide if I'm gonna do this or not. I feel a little bit weird about talking about how to be an effective murderer on stream. But yes. Oh, thanks so much for the host, dude. Technically, yeah. I mean, there might be other things that are telling you that it's not a burial versus it being a murderer stashing a body inside of a casket. So it might not be like be all end all, like this body's hidden, we're just going to assume it's a burial. There's probably some other tells that we could find. I know, right? Asking for a friend, no big deal. So I would guess there's probably some other contextual clues that might be like, okay, this might not be right. But also, I feel like if you're going to go to the trouble of murdering somebody, I would feel like it's probably pretty rare that someone would actually take the time and spend a crap ton of money, because caskets are expensive, to actually bury somebody like that. I mean, I guess if you're really determined, but this is awkward. I do not condone murder. Let's just say that. So yeah. Another thing is if you find somebody who is laid down face down. So you might have a supine burial, but actually they were laid down face down as opposed to face up. That's another big clue. That's somebody probably just throwing a body into a pit or something like that. And yeah, so that's a big clue. So this is kind of just a quick aside. This is something I'll talk a lot more about when I get to actually doing recoveries. All of this information about how the burial is laid out is all contextual information that you can only get if you are involved in the actual systematic recovery of the remains. Because this is all contextual information that is basically evidence. It's serving as evidence to you, and is giving you information that's important. And so if you don't have a systematic recovery, say law enforcement just find a bunch of bones, they pick them up, bring them back to the lab. I can only do so much with that, and there's probably a whole bunch of contextual information that that can tell me whether or not we're dealing with a forensically relevant case, and that information is lost if it's not systematically documented during a recovery process. So I just wanted to kind of say that, because like whether somebody's face down or erratically placed or whatever, that's all stuff that would get documented throughout a recovery and mapping process. That's all information that we need to know. Are there any cultures that have buried their people face down? Not to my knowledge. I am not a cultural anthropologist or a historical archaeologist, so I don't know too much about burial customs, but most of the ones that I'm familiar with, at least, are either going to be supine or prone or flexed. So I don't know of any. It's possible, but not to my knowledge. Good question, though, because that could be, like, depending on where you are. If you are in a particular area where a local culture is known to have done something like that, then that's, again, another piece of information that you're taking into account. So, all right. Okay, here's another one, cranial modification. So this is one that can help us figure out if we're dealing with prehistoric remains or otherwise, for the most part. There are various types of cranial modifications that you really only see if you're dealing with prehistoric remains, and specifically mostly Native American or other indigenous groups. It doesn't have to be Native American, it could be indigenous people in South America, or I guess that's still technically American, but but yeah, so there's a whole bunch of different kinds, and these are different techniques that are basically linked to sort of beauty standards. It's usually something that's done when someone is still a kid, so your bone is still growing and shaping itself. And so basically what you do is put some sort of apparatus around the skull while it's growing, and it just stays there. And so this one on the left here, where you have this really, really elongated skull, this is like those I feel weird saying it, but this is how they're usually talked about, the alien skulls. Like, this is kind of like Kingdom of the Crystal Skull with Indiana Jones, the like fourth movie that everyone pretends didn't actually happen. But this is essentially what that is, and this is something that did show up in the archaeological record. So the way you would do this one is that you actually wrap an apparatus around the skull and just basically constrict it so that the only direction that the skull can grow in throughout development is backwards. So it just restricts like growth in this direction so that it can only go backwards. So you end up with this kind of cone head sort of look. There are more tame versions of this. For example, this one here. Oh, this one right here, actually, this is sort of a lesser version of this one. You can actually see that there's a dip here where there was something that was binding the skull and keeping it from growing. Is there any evidence of that affecting the brain? I can't imagine that it wouldn't. I feel like it would have to. Theoretically, your brain is also going to be shaped just like this. I don't know how that would affect function, but I would be really surprised if it didn't. That would be kind of a miracle if it didn't. But then this one up here is a more subtle version of this, and this is called cradle boarding. So basically, cradle boarding is a practice of a lot of different cultures where a kid is sort of swaddled up on a cradle thing and then put on like a backpack. And so you'd carry around your kid on your back, and they're swaddled up in this thing, and their head is resting right up against the board that's on the back of it. And so essentially for potentially several years, I mean, obviously they're being let out, but for many, many hours, for over a long period of time, they are wrapped up fairly tight into that board. And so the back of your skull is actually growing while being pressed up against that board. So you end up with kind of a flattened back of the skull. So that's something that's pretty common. That I would say is the most common form of cranial modification that you might actually come across. And so that's basically going to tell you that you're probably dealing with prehistoric remains, because this isn't really anything that happens with modern remains. Okay, we're nearing the end here. So hey, Color Circuit Live, how's it going? You are also in Albuquerque. I just found you guys, so welcome. Yeah, it does happen today. So you can have, I don't know if you've ever seen babies that have the helmets on. So this is something that does happen. Like if a baby kind of lays on one side too often when it's sleeping, this will happen. They'll end up with kind of a flattened spot. So you either have to kind of train them to move around more and not stay in one place, or you end up with these little helmets. And it's basically just a way to kind of preserve the roundness of the skull while it's growing. So, and then at some point you don't actually have to do that. So cool, you work in Earth and Planetary Science. That's awesome. I work in the Anthropology department, so, which is right across the way there. So super close by. Awesome. Welcome. Okay, so the next big thing that we're going to look at is dental attrition, which is just a fancy way of saying wear. Or wear and loss, I suppose. So are you eating super hard foods over the course of your lifetime that is causing your teeth to wear down really quickly, and maybe even you lose them? This is also something that you see when you don't have modern dental care. So if you don't have access to dental care and you're also eating super heavy duty foods with lots of grit and like dirt and rocks and stuff that might be in there, which is common in if you're processing corn, cultures that process corn, oftentimes prehistoric cultures will use basically a big rock and then another big rock to sort of pound it out, and then you're making masa and all of that with it. And when that's happening, that rock is kind of breaking off little pieces of grit, and that's getting in your food. So you would potentially be eating this kind of stuff. So basically all of these different types of practices throughout life are going to make you lose your teeth. And if you do still have the teeth, they're going to be heavily, heavily worn. So for this example here, you can see there's a bunch of different teeth that have been lost. And then these guys here are severely worn. You can see so this whole area right here is called dentin, which is the inner structure inside the tooth that's underneath the enamel, which is the white part that you normally see. And that's just a normal process. Every single one of you probably has a little bit of dentin exposed, depending on how old you are. And you'd be able to see that in the mirror. You can kind of go look, you might see a slightly darker little line or a dot or something, and that's exposed dentin. So that's a normal thing, but it means that there's less enamel there. There's probably going to be some more sensitivity, and you're never growing that enamel back. You have the full amount of enamel you will ever have when your teeth are formed. You never regrow it. It's not like bone where it remodels constantly. So you end up with these severely worn teeth. And so if you see this on remains that you might find, potentially you're dealing with probably prehistoric remains, maybe historic also, but most often you're probably dealing with prehistoric remains. This isn't to say that you wouldn't necessarily find severely worn teeth in modern individuals, but this is just sort of one piece of evidence that might point to a later time or earlier time period. But it's in conjunction with all of this other stuff that you're finding, all these different contextual clues that are telling you that it's probably older. So artifacts, this is a biggie. So I already kind of mentioned funerary remains. That's a biggie, but that's kind of burial specific. Outside of a burial context, you might also find pretty much anything else. There could be clothes, there could be a wallet, there could be shoes, there could be pottery, there could be a phone or whatever it is. There's any number of things that could be found with a set of remains. And the key here is that these artifacts need to be associated with the remains, which means that they're kind of generally in the same area, and it's reasonable to assume that those artifacts were probably associated with that person when they were alive, which may or may not be true. If you find a burial with funerary remains in one part, and then 50 yards from there you find an old iPhone that's been thrown out, probably not associated. Doesn't mean they couldn't be, but that would be weird. So in any of these contexts, you're essentially finding something that is giving you a clue to when this particular set of remains came from. If you're finding stone tools, you're probably dealing with prehistoric, or maybe it's an archaeologist who learned how to flint knap in a class, and now they've been buried and they wanted to take some of their flint with them. That's one other place you might find that. But pottery, other textiles, those could be associated with a particular prehistoric group, and maybe by the style of them, you can potentially date those. So figure out what time period it's from, potentially what culture you're working with. That's all context specific as well. So if you're in New Mexico, we'd have probably a small subset of possibilities, whereas if you're in Arizona, you might have a slightly overlapping group of possibilities, but maybe some different ones. So it's all dependent on context. But obviously, if I find some coins, there's a date on coins. So that's telling me that that coin existed before this burial happened. So you know that the date on that coin is this burial that you found is at least as old as that coin, because that coin had to be produced during that year. So for this Sacagawea dollar coin here that was minted in 2003, you know that that burial has to be at least as old as 2003. Do we know when coins started being dated? Oh, good question. I do not know the answer to that. I would say probably several hundred years. Oh, wow. So according to Wikipedia, just after a quick Google, early coins, all Western histories of coins were invented at some time slightly before or after 700 BC. Oh, these were the earliest issuers of coins, but not necessarily dated. You would be able to date them based on the style, probably. Hey, Hosebeats, what's up? Romans kind of did it. Oh, you put the current emperor on it. That's a good point. Yeah, so it might not have like a physical number, but it might have some information on there that you can use. I'm gonna look that up. I'll get back to you guys. That's a good question, actually. But really, the point of all of that is that if you are trying to figure out what the date is of a coin that looks super, super old and is not one of the coins that, is kind of a modern coin with a date on it, probably not dealing with modern remains. So there's still some information there. Yeah. So yeah, if I find an iPhone, stuff like that, that's all probably going to tell me that I am working with some modern human remains. So obviously, you're not going to find an iPhone in a prehistoric remains unless somebody's trying to screw with you, which is possible. But I'm definitely going to look into that more. That's a good question, actually, about the coins. I just want to know. All right, so I think this one's the last one. Yeah, okay, so other things that we might look for to figure out if we're dealing with modern versus otherwise. These are just kind of random things. Most of this is giving us clues to a modern context. So odor. Are the remains stinky? If they are, it's probably relatively fresh. Not talking about a 100-year-old burial. 100-year-old burials have a different smell, but it's not gross. They definitely have an odor, but it's different. It's mostly musty and stuff like that. Is there insect activity? Most often, if you have insects that are kind of doing their magic on a set of remains, that's probably pretty fresh as well. Usually odor and insect activity go hand in hand. And this isn't to say that there might not, or that there wouldn't be insects potentially involved in an older set of remains, but it's a very different type of activity. You're not actually going to have active insect activity on the remains. They might just be kind of in the surrounding dirt or something like that. So it depends. Colors. So if you have kind of different types of staining, you might have fat deposits. This is something called adipose sear, which is, I'll type it in chat, it's kind of a weird spelling. So adipose sear is when your adipose tissue, which is fats, kind of degrade through decomposition, and you end up with this sort of like chalky white substance that can deposit itself on bones. Usually this only happens when the remains are decomposing in a wet, kind of moist context. And you might have sort of pieces of adipose sear that are sort of sitting on top of soils. This can actually be a way to tell that there might be a burial underneath if you find adipose sear on the surface. But it can also stain the bones. So that might tell you that it's a recent decomposition process, probably in a wet environment. You might find blood staining, so that's recent decomposition as well, and soil staining too. So you might have bones that are stained by the soil that's surrounding it, and that happens over a relatively long period of time. So if you see a significant amount of soil staining on the bones, then it's probably been in the dirt for a while. So it still could be modern, but it might just be older. So all of these are kind of giving you clues whether you have had decomposition recently or if the bones have been in the ground for a really long time. Soft tissue seems like the most obvious way to do this, and if there is soft tissue, especially like very fresh soft tissue, or perhaps like active decomposition going on, then yes, probably a pretty fresh burial. But that also depends on where you are too. So obviously a lot of environmental concerns here. Depending on what environment you're in, you're going to decompose slightly differently at a different time scale, those kinds of things. If you have sort of older soft tissue that's present, like say mummified tissue, kind of like that black bear paw that I showed earlier, that's going to be potentially something that's older or recent. Just because that soft tissue is there does not necessarily mean that it's super, super recent, because if you have mummified tissue there, which is usually what's going to happen when you're in a very dry environment. So here in the desert in Albuquerque and New Mexico in general, mummification is pretty common. And this is natural mummification, obviously not like Egyptian mummification. But that's something that can stick around. Once the tissue is desiccated enough to become essentially mummified, it's probably going to stay there. Actually, hang on a second. There we go. Show and tell time. Okay, so this is a horse pelvis. This is up on our mantle. If you've watched Science Happy Hour before, you've probably seen it. And this particular horse pelvis has some remaining soft tissue on it, and right here. So this whole area is soft tissue, and this is mummified. So this is like brown, sort of dried out skin and muscle tissue that's right here. It's not gross. When it's mummified, it's really not that gross anymore. You've got some connective tissue up here that's sort of in layers, and you can tell that it's soft tissue and not bone. There's a bunch inside the acetabulum, which is the joint where your femur articulates with your pelvis. So there's a whole bunch in there, and that's all. Oh, there's actually a spider web thing in here. We should probably get rid of that. That's gross. Like, eh. But anyway, so there's some bug that's trying to live in here. That's nasty. But yeah, so this is all mummified tissue. It's kind of brown, kind of sits on top of it. And when it's like this, it's probably been there for quite a while, and this isn't going anywhere. So, is mummification just desiccation? Pretty much. That's essentially what it is. Yes, hose beats, that is exactly what just happened right there. I'm totally okay with the mummified tissue, but the spider, not a fan. So yeah, that tells you a lot about me. So that's what mummified tissue looks like. Let's see if I can put this back. Sorry, you're just staring at my butt probably. So anyway, but yes, mummification is essentially just desiccation. That the tissue is dehydrating enough that it's not going to kind of disintegrate like you would see in non-dry contexts. Mostly that's what's happening, is the skin is just kind of, all of the muscle tissue is usually going away, but then you have skin that's sort of just dried out and kind of just lays on top. So that's pretty much what it is. Okay, so those are the main things to tell modern versus historic versus prehistoric remains. Obviously, if it's modern, doesn't necessarily mean that it's forensically relevant, because you could have a burial. You could have a burial with casket hardware and stuff like that. So, hey, Enforcer, thanks so much for the follow. So it's not necessarily just that it's modern that makes it forensically relevant. Then you also kind of have to look at, again, all of the context involved in all of this to figure out if you're dealing with something that requires an investigation. So is there signs of trauma? Is this person where you would never expect them to be, and it doesn't look like it's a burial, but it's modern remains? All of those things sort of come together to tell me that, okay, I probably should investigate further and find out who this person might be. So that's essentially what's going on there. So we know that it's bone, we know that we're working with human bone, and we know that we're working with not only modern human remains of somebody who was probably deposited somewhere within the last 50 years, but we're also looking at something that is not an expected thing. So foul play in a weird place where you wouldn't expect somebody to be buried. There's no evidence of like burial hardware and stuff like that. So then I'm probably going to start to investigate. So that's basically the first thing, I guess the first things that you have to do when a case is brought to a forensic anthropologist. So anytime a case comes in, many of these things are not known at that point. So you're basically going through and figuring out if you have bone, if it's human, if it's modern, all of that, and then deciding, okay, yes, we need an investigation. So that's the first step. So once you establish that you're dealing with medical legal significant remains, then everything else kind of comes from there. So that's the main thing. Do you guys have any other questions on medical legal significance? Again, you can do a lot of this stuff, right? If you go out in the woods and find some remains, you might now be able to tell that you're working with humans. So, you know what? I think I might have skipped a slide somewhere. Where did it go? There we go. I skipped a slide. Here's another thing that I forgot to talk about. I don't know what happened, but it did not show up. But another big thing is size and level of maturation. So that horse pelvis is humongous. Obviously not a human. But you might find something that looks like a tiny animal, but in fact it's really just a baby. You might have some juvenile remains that are really small, and you could find a baby animal too, but it's all about how it's all about how developed something is versus how big it is. So if you have remains that are really, really big but are still unfused and it looks like it's a juvenile, it could be human. But if you have something that's really small, on the surface it might look like it could be a baby human or something like that. But if it's fully developed and small, then it's probably an animal. So that's one thing that I kind of forgot to talk about. So you're looking at size and sort of the level of development all at once. So I forgot to mention that, but yeah. How long can determining medical legal significance take? Oftentimes, you could probably do this in the field. So if if we're called out on a recovery and somebody maybe found some remains and they want somebody to come look at it and potentially start an excavation process, you would probably be able to tell this right off the bat. You're kind of looking at all of these different things all at once, so it's kind of like a gestalt view of the remains, but you can probably tell most of this pretty quickly. If you have a set of remains that don't necessarily require a recovery, if you just have remains that are sent to you, say it's a bear paw or something like that, you're gonna have to do all of this stuff. That's pretty instant too. If you want to be sure, say you can't really tell from just the morphology or something like that, and you want to do a radiograph, or maybe you do a thin section so you can look at histology, that could take a little bit longer, but that's really only necessary if you can't tell by these other things. So those, if you have to use a specific technique that requires equipment and stuff like that, it'll take a little bit longer, but for the most part, we can probably tell these things in the field pretty instantaneously. So that kind of comes with experience, I guess, but it's all about context. So it depends on what context you're in. Any other questions, guys? You'll probably hear me harp on context over and over and over again in this, and I tell this to my students too, because that's really what you're trying to do here. Even though I'm, as a forensic anthropologist, using the similar toolkit in terms of my skills as a biological anthropologist or bioarchaeologist or something like that, the fact that this is all happening within a forensic context as opposed to an archaeological one means that I have to do things very, very differently. All of this stuff has to happen in both of those contexts, but if I'm dealing with something that's forensically relevant, then I have to do different things. I have to have a chain of custody, and I have to be thinking about the fact that everything I'm doing while working on that case is potentially going to be tried in a court of law. If you're lucky. That's not always the case, but it may not get that far. But if it's going to be tried in a court of law, I have to be able to defend all of these things on the stand. So it makes for a very different set of tools that you have to use. How long have I been studying anthropology, and have I always? Yes. I have been studying anthropology for, let's see, I'm in my 7th year of my PhD. I did 2 years of a master's and then 3 years of undergrad. So that would be 12 years of studying anthropology. So yeah, it's been a long time. I've been doing forensic related anthropology for probably 10 of those. I didn't really specialize in forensic anthropology, or at least like try to set out on that path until probably my junior/senior year of college, I guess. So yeah, so probably about 10 years that I've been studying this stuff. I got my master's in forensic anthropology in 2011, so I've had that for 6 years. And I've been doing it kind of on and off, either being a TA for the forensic anthropology class here at UNM for most of the first few years, and I've been teaching it now for 3. This is my third year teaching it. So, have I ever worked or studied at a body farm? No, I have not. I know many people who have. I have done a lot of research on what goes on there, so I know a lot about how it works, but I have never actually worked on one. I almost went to the University of Tennessee in Knoxville, where they have the most famous one. But to be perfectly honest, that part of forensic anthropology does not interest me very much. I am not really that psyched about gross stuff. Bones and stuff doesn't really bother me at all. But as soon as you have to go watch a body in full bloat and like watch it explode, because that actually happens, yeah, I'm not into that so much. So I don't necessarily want to study decomposition and time since death and stuff, which is mostly what they're doing there. So it is very stinky. You cannot unsmell that. I will never lose the scent of human decomposition, or just decomp in general. It's gross. Yeah, it's not fun. If I had to choose another field of study outside of anthro, what would it be? Is this in this world or in any world or universe? Is this like a hypothetical, or like, say I can't do anthropology or something? Is that what you mean? Because they might be different answers. That's why I ask. If it was sort of any world or universe, I've kind of always wanted to be a volcanologist, and I've talked about that a little bit before. I think volcanoes are so freaking cool, and I feel like I might have done that if I had kind of taken a different path. I think it's super, super cool. Other than that, like in this world, I could do anatomy stuff because I've done a lot of that. Potentially a lot of people who study forensic anthropology but don't end up being a professor or something like that will end up doing criminalistics, so you can actually go do death investigations. I have some friends who became cops. Yeah, it all kind of depends. So, but I like teaching, and I like hanging out with you guys and teaching in this kind of setting. So that's really where I'm kind of moving. So, ooh, professional adventure, that sounds awesome. That does sound awesome. It sounds hard to pay the bills though. So maybe if you have a travel show or something, you could do that. So, oh, cool. Yeah. Ooh, Tobias Fisher, nice. Yeah, we actually have a volcanology student who comes on Science Happy Hour pretty frequently, Kristen Rahilly. I think you might know her, actually. But yeah, she's getting her PhD here at UNM. So yeah, I would love to go on one of those trips. So we have several volcanoes right outside of Albuquerque, or maybe even in Albuquerque, but they're long extinct, so they're kind of boring. But yeah, planetary geology, that sounds super fun. Oh, I love graphic design stuff now. I've started doing a lot of it for the show. Like I made this lovely overlay that we're hanging out in right now. And I totally go down graphic design rabbit holes. It's actually really fun. I really like hanging out and playing in Photoshop. So, but yeah, cool. Yeah, planetary geology sounds super fun too. I feel like Hosebeats might do well at that as well. So, which he's kind of already doing, but he's a hydrologist. All right, any other questions, guys? I think I might wrap up here. I'm gonna go get some brunch or something. Take my parents somewhere and do something fun. But yeah, thanks for hanging out with me, guys. Next week we're gonna do the skeleton, so it'll be a little bit longer, I think, because I'm gonna go through the whole human skeleton and we'll learn all bones. It'll be super fun. So, but thanks for hanging out with me. I hope you guys come back next week. Like I mentioned last time, this is sort of set up like a class, so it is sort of linear in terms of what you can learn, and I'm gonna do it just like that. But also, I'm hoping that each one of these you could still also get something out of it. So you don't have to watch all of them, but I wouldn't mind if you came and hang out with me again. So, all right. Well, I'll talk to you guys next week. We've got a couple other shows. We've got 2 podcasts, and then Science Happy Hour this week. We're talking about exercise science, so we can talk about a bunch of like weird exercise fads and stuff like that. So, all right, thanks for hanging out with me. Thanks for the follows and hosts and everything. And I hope you guys had a fun time, and I hope you learned something. So I had a good time hanging out with you. So, all right, bye guys.